Okay, so they gave you the number pattern, right? 13, 10, 7. So from this, we can see that A is 13 and D is -3, right? And then they're asking us which term in the number pattern is equal to -44, so you make that equal to Tn. So here we use the Tn formula, but then we make it equal to -44. You sub in your A value, your G value. Now this solving for n is maybe a bit different from the way that you did it. It's fine if you actually multiply the -3 into the bracket and then move stuff across and then divide it by -3 later on. That's fine, you would have gotten the same answer. This is just another way of doing it. So what I did was I moved the 13 over first. I said -44 minus 13, I got that. Then I divided that by -3. I was left with n minus 1, and then I added 1 on the other side. Okay, but it's up to you if you want to do the normal of like multiplying it off, that's fine. But the answer there was term 20. Any issues with that one? Okay, then we have 4D. Okay, so we have practiced ones like this before. They've given you the values of terms 9 and 19. So for term 9, you write that as 8 plus 8. Term 19 is 8 plus 18. Make A the subject. Sub that into the place of A in the other equation. Solve for D. Sub that in there to solve for A. And then they ask for the first 3 terms. So A is term 1. Then you minus 3 over 2 from that. 1, 0, 12.5 here, or 12.5, that's 35. And then minus 3 over 2 again. All right, 6 was A and B. So for 6A, they wanted you to find the value of term 12. So I just wrote it that term 12 is A plus 11B, but you didn't have to do that in a separate step. You could have actually done this. This could have been your first line, right? We're actually subbing in your A value, your first term. Plus, you could have written 12 minus 1 in brackets, because it's n minus 1. So 12 minus 1, I will go to 11. And then D is your minusing 4 each time. So D was -4. And then we end up with -1. And then 6B was just like what we had in 3C, the first question, where they now are giving you the value of a specific term and they're asking which term is that. So you make that into term n. And just like in the first question, again, I subbed in my A and my D value. I have my n minus 1 there. So now we must find n, right? If they're asking us which term. So we don't know what n is, that's what we need to calculate. And the term that they've given us is now equal to Tn, -52. Again, whichever method you use to solve for n is fine, as long as you get into 20 in this case again. Question. Then number 9 was the last one. So 9A was like that example that we did yesterday, where they gave you the first 3 terms and you must find x. So I did term 2 minus term 1 is equal to term 3 minus term 2, because it has that constant difference there. And then I just got that x is equal to 1, and they actually also asked for the first 3 terms in this case, in the same question. So you just sub in 1 into each of them, you get 3 to 1 is the first term. There's 3 on it. Then they asked for the general formula, the n term or something, I can't remember the wording there. So now you do your A plus n minus 1D, and this is now where you sub in your first term and you sub in your difference, which was -1, and you then simplify. So I got 4 minus n. You also could have written -n plus 4, that's fine. And then from there, I actually use this formula to answer the following question. So then they asked for which term is -41. So again, when they're asking us which term it is, then we need to make term n equal to that. But now do you guys notice that I use this term in formula instead of a plus n minus 1b. Right? You could have used a plus n minus 1b and just sub in 3 and negative 1 and then equal what? We could have done this. 3 plus n minus 1 times negative 1 equals negative 41, like that. And then solve for n there, you would have gotten the same answer. Okay, it's fine to do that. I just used the actual formula that we calculated in the. So guys, fine with this, with the two options here. And then for G, they asked for term 20. So again, I used the formula that we calculated, because this formula will give us the value of any term in this number pattern if we just sub in the n value. So if you're asking for term 20, 4 minus 20 is going to give us that term. Or if you forgot about that formula, you could have just worked with a plus 19b, and again subbed in your a value and your g value and your g. Okay, so it is up to you guys. Both will get the same number of marks. Okay, any questions on this, guys? Any questions on arithmetic progressions in general? We're moving on to arithmetic series today, which is similar but slightly more. Yeah, there is a bit of a difference. Okay, so that is the new heading, arithmetic series. Right, this chapter is called sequence of series. We don't know what a series is. I'll explain to you now. Okay, so arithmetic series, we're going to call this an AS. All right, so an AP is an arithmetic progression, an AS is an arithmetic series. So AS. Now, an AP, for example, that's what we've been working with so far, is like when we have 4, and then 7, and then 10, and then 13, and then we can carry on like that. Right, that is an arithmetic progression, so it's a linear pattern, right? We are adding 3 every time. Now, an AS has the same property. We also have a constant first difference with an AS, with an arithmetic series. But the difference is when you have a series, you're actually adding the terms together instead of just listing them. All right, so it's the same thing. We still have a difference of 3 from one term to the next, but now when we add them together, we call that a series. So that's plus 3. From 7 to 10, that's plus 3. From 10 to 13, that's plus 3. Now with an AP, when it was just the list, right? It was just the number pattern listed. We only worked with this formula. We worked with the Tn equal to A plus N minus 1 formula. Right? And that would give us the value of a specific term in the number pattern. Now that's because this number pattern, right, even though it's a series, we still have the same thing. We still have a G value, right? We are still adding 3. We can still use this term formula if they ask us for the 20th term in this series. All right, we can still use the Tn formula to find the value of the specific term. right? That formula still applies. Or if they tell us that term 10 is something, we can still write that as A plus 9B. All right, we can still use this formula just like we've been using it. But now because we're actually adding the terms together, we can now calculate the sum of a certain number of terms. All right, here I've written 4 terms. So I can find the sum of the first 4 terms. I can also, we're going to write down the formula now, find the sum of the first 50 terms. All right, without actually having to write down all 50 terms and adding them together. We are going to use the SN formula, like that. S is now the sum of the first however many terms. All right, if that is a 4, it's the sum of the first 4 terms. In other words, when you start the values in, it's going to give you the answer when you add these 4 together. Okay, but if you put in a 10, it's going to give you the value that you get when you add the first 10 terms together. All right. Now this formula is one that we are going to prove. We're not going to do that today, but we will do the proof for this. So we start with n over 2, square bracket, 2a plus n minus 1b. So it's similar to the term formula, but we are multiplying the bracket by n over 2, the number of terms divided by 2, and then instead of an a that we have in the term formula, we have a 2a. Okay, when we prove the formula, we'll see why that happens. All right. Let's quickly actually calculate this. If we obviously we can work this out by adding them together. What is the sum? If we just do it manually, 4 plus 7 is 11 plus 10 is 21 plus 13 is 34. All right, so this sum here, we can see the sum of these 4 terms is 34. Let's see quickly if we actually use this formula to work it out, if we also get 34. Right? Obviously, if it's just 4, then it's easy to just add it together. So, but I just want to show you how the formula works. So we would say sum to 4 is equal to n over 2. If it's a sum to 4, how many terms am I working with? 4. So 4 over 2. If you want, you can write 2 straight away. Square bracket, 2 times a. A is still the first term, right? What is the first term of this number pattern? 4. Plus a minus 1. What is my a value? If it's a sum to 4 terms, it is 4. So what's 4 minus 1? 3. What's my constant difference? 3. I'm adding 3 every time, right? Then you close your bracket. Okay, let's work that out in our head because it is easy to do. We have 4 over 2, which is 2. Right? And then in this bracket, what's 2 times 4? 8 plus 3 times 3, which is 9. 8 plus 9 is 17, right? And what is 2 times 17? 54. Okay, so we're just by looking at that example, we see that the formula does work. It does work. So that's all of the variables that we learned with the term formula. Those variables still apply to the sum tool. All right, n is still the number of terms. A is still the first term. B is still the constant first difference. Okay, now we're just adding something to it. Now instead of just finding terms, we can now actually find the sum when we add some of those terms together. Right, this sum formula only works from term 1 to however many. Okay, this formula is not going to give you the sum as we go from term 10 to term 20. All right, it has to be term 1 to term 4 in this case. All right. I just want to see here. Let's just do this. These 2 examples, and I'm going to give you some to do. So this is just an example of applying the formula straight if you just have the different values. But of course, they can swap it around, they can ask us different things. So examples. how many terms in the arithmetic series 34 plus 40 plus 46 will add up to 1,500. Okay, so they're saying will add up to. So does it make sense that this is the sum that they're given? Right? If they use the word will add up to, then this is the sum. All right. And do we know how many terms we added together? No, that's what we're calculating, right? So we are going to make the sum equal to Sn. And then we're going to have to solve for n. All right, how many terms is n? We want to know how many terms do we have to add together to actually get to a sum of 1,550. All right, so we're going to say sum of n is equal to 1,550. Now guys, this is the number pattern, the series in this case. Do we agree that A is 34? Right? So in our formula is inside in 34 for A. What is the constant difference here? 6, right? Do we see that? We are adding 6 each time. So D is going to be 6. I'm just going to rewrite this formula because we haven't used it a lot. So just so that we get used to it, I'm just going to rewrite this. I'm going to say n over 2 square bracket 2a plus n minus 1d is equal to Sn. Or you can put that 1,550 straight away. You know? Remember, n is what we're going to calculate. We don't know what that is. Now, do we notice that we have two n's in this equation, in this formula, right? So we're going to have n's in two places. So we have n over 2 square bracket 2 times a, which is 34 for this number pattern for this series, plus n minus 1, which stays n minus 1 because we don't know what n is, times 6. That is equal to 1,530. And I please note that we have a fraction in front of the square brackets. How many terms do I have here on the left-hand side? I have 2 in the bracket, right? But in the whole left-hand side, I actually only have 1 term. So what we can do to get rid of this 2 here, on this side, I'm dividing by 2. So on the other side, I can just multiply by 3. All right, then we've gotten rid of that fraction. So we can have n, and let's actually simplify the square bracket now while we're busy. 2 times 34 is 68, plus n times 6 is 6n, and negative 1 times 6 is negative 6. Equals, now remember to get rid of this over 2, we have to multiply by 2. Right, so 1530 times 2 is that 3060. Thank you. Okay, now what? We can multiply the n, but we can also just simplify this first if you want. Again, it's up to you. I'm going to leave that n there for now. I'm going to write this as 6n plus 62. Do you guys see where I got that from? Because in the brackets, I have to say minus 6, right? Which is 62. And that is equal to 3060. Are you guys noticing what's going to happen now when I multiply that in? Get a 6n squared, right? 6n squared. Quadratic equation, here we go. Plus 62n. And because it's a quadratic equation, we know that we have to have everything on the one side equal to 0. So this 3060 we must remove. It's going to become minus 3060 equals 0. Well, guys, who is going to spend time on trying to type that? This guy. Not me. I'm going to use the quadratic formula. All right. You could actually simplify this and divide through by 2, I think, which is fine. Is it by 6? Yeah, I think you can divide through by 2, but it's fine. You don't even have to do that. If you're going to use the quadratic formula, you can start this in right from the start. Okay. Right now, I'm going to write x equals. N equals, please. N equals, let's just rewrite the quadratic formula. We haven't used it yet this year. Minus b plus or minus the square root of b squared minus 4ac over 2a. And a, b, and c are the values that we have in our quadratic equation. So my b value is 62. So negative b is going to be negative 62 plus or minus square root of b squared, so 62 squared minus 4. My a value is 6 and my c value is very important, negative 3060. If you leave that negative out, guys, it's going to come back as a math error. I think we did discuss that last year, because you're going to get a negative value in the square root. Okay. Divided by 2 times a, which is 6. So divided by 2 times 6. Remember, very important, you have to show this step. You don't have to rewrite the formula like I did now. You don't get a mark for doing this. You do get a mark for doing this. So maybe make a tick there and highlight it to remind yourself that you will lose a mark if that step is not there. All right, what are we getting? Can you type it in?
So the closest one is 6,405.
Are you sure?
Oh,
Then double check.
oh my gosh,
What did you do?
I didn't do the thing.
This thing?
Yes.
Okay, that explains. Okay, so 80.
Sorry.
No problem. Yes, thank you. Don't worry, we can all learn from your mistake. Okay, there we go, guys. It is a quadratic equation, so we'll get 2 in values. Now we need to remember what is in this case. It represents a specific thing, right? It's the number of terms. So can I firstly have a negative number of terms? No. And also, even if this was positive, can you have a fractional number of terms? No. All right, so this answer is invalid in this context. All right, if it was this solve for x and you had this equation, then they would both be fine. But because we're finding the number of terms, the answer has to be 18. All right, so please draw a line through that equals and just write underneath it, invalid. But remember, you do have to show both answers and then state that the one is invalid. Okay, so therefore, the sum of the first 80 terms of this number pattern will be equal to 1,550. As long as it's extra, you don't have to write that down, but let's write it down so that we understand what we're actually doing, what our answer actually means. Okay. Any questions? So guys, we're not going to do quadratic equations again as a separate chapter like we did last year, but you'll see it's going to keep popping up in all of, well, not all, but most of the topics that we're going to be doing. Yes. No, so I said now you don't have to write this, but I'm writing it down so that my answer actually makes sense. But you won't lose a mark if you don't write it. I also just wanted to mention to you, I think I didn't say last year, but this year for all your tests and exams in maths, you get the formula sheet that we will be getting at the end of the year. So this formula, if I'm not mistaken, is actually the first thing on that formula sheet. It obviously says x. So you would just have to change the x if you're finding n. But yeah, so it is there. But it helps if you know. That's true. Okay, second example. Yeah. Thank you. Guys, when I'm done writing this, I'm going. Yeah, I'm gonna wait for you guys. Thank you. Get good. Can we go? Yeah, almost. Okay. Ready? They're saying the sum of the first 10 terms of an arithmetic series, sorry, is 60. Okay, so let's rewrite that in like mathematical notation. So we're going to say the sum of the first 10 is 60. Right? Then they're also telling us that the sum of the second and sixth terms is 9. Okay, we can't use the sum formula for that because, like I said, the sum formula only works in this case where they're saying the sum of the first 10, right? Or if they say the sum of the first 6, the sum formula only works from sum 1 to a specific term, right? So they're just saying the sum of the second and sixth terms is 9. We're going to have to write it like this. Second term is term 2, and then how do you get the sum? Right, I will write it out. You write that out for me. Term 3 plus term 6 equals. The sum of the second and how do we find, yes, that's just it. How do we find the sum of two things? We have to add them, yes. Term 6 is equal to 9. So now we're going to use the sum formula to express this in terms of A and D, because we know what N is, right? N is 10. Is that clear to everyone? Then we're going to use the term formula twice. So how can I write term 2? That's going to be A plus 1B, right? Do we remember? Let me write the two formulas here. The sum to N formula, which we're going to have to use here, is N over 2 times 2a plus n minus 1b. And the term formula, which we're going to have to use here, is a plus n minus 1b. Right, if they've given us a term, we need to work with the term formula, okay? Even though we're working with the series here. Okay, so let's start from this side. If n is 10, we're going to have 10 over 2. You can write that as 5 if you want. I'll try 10 over 2 for now. Bracket 2a plus n minus 1b. What is n? 10. So 10 minus 1d is 9d. So how do you do that? Right? N is 10. So 10 minus 1d is 9d. That is equal to 60. And then I simplify this straight away, guys. What's 10 divided by 2? 5. And then I can divide 60 by 5, okay? Then I get rid of those brackets. So this is 5 times the bracket. What's 60 divided by 5? It's 12, right? It is 12. Yes, indeed. There we go. Okay, so I've just simplified that a bit, that equation. I've calculated that this is 5, and I'm saying divided by 5 is 12. So that's what I did there. Now term 2, I'm going to have to write as a plus 1b, 2 minus 1b, right? Plus term 6, how can I write that? Term 6 is a plus 5d. And that is equal to 9. Since we have like terms, let's add them together. A plus a is 2a. Plus d plus 5d is 6d. And that is equal to 9. We have two equations with two variables. So we have to solve them simultaneously. Now guys, usually we have to make a the subject. But in this case, we notice that we have a 2a and a 2a. Right? So you can actually just make 2a the subject and then sub it in the place of 2a in the other one. Yes. Yeah. So term 2, if we were working with this formula, is a plus 2 minus 1b. And 2 minus 1 is 1. So that's where 1 b comes. So this is term 2. Okay. And then this, yes, then this is term 6. All right, so let's do that together. 2a is then 12 minus 9d. And then, like I said, I'm not going to now make a the subject because there is a 2a there. I can just sub this expression into the place of 2a straight away. All right, we can save yourself some work there. So then from there, 2a is now 12 minus 9d. So that is now 2a plus 60 equals 9. Negative 9d plus 60 is negative 3d. Then move the 12 over. What's 9 minus 12? Negative 3. That's quite nice. D is equal to 1. Yeah. No, it's fine. Oh, it's fine. Okay, so now if we have the equals 1, we're going to sum it in there. That's going to give us 2a, then we must just divide by 2, right? So then we can say that 2a is 12 minus 9 times 1. But you don't actually have to show that. Okay, I'm just showing you where I'm getting it from. And 12 minus 9 is 3, right? Is that correct now? 12 minus 9 times 1. 12 minus 9 is 3. Right, so 2a here is 3. So a is 3 over 2, 1.5. Yes? Okay. What did they ask for in the question? Determine the first three terms of the series. Guys, this is important. If they're saying series, you have to write the terms with pluses in between them. Okay, that's important. If you don't, you might lose them off. Depends on how strict they're marking, but you never know. So therefore, my first term is 3/2. Then I must put a plus because they're asking for the series. What do I do to get my next term? My constant difference is 1. So I can say 3/2 plus 1, which is 5/2, right? You can use a calculator if you want to, but 3/2 is 1.5, so this is 2.5. You can also write it like that, or in decimal form, that's fine. And then plus for the third term, we have 5/2 plus 1, which is 7/2. Okay, and don't work that out because they didn't ask for the sum of the first three, they just asked for the first three. Okay, you can just leave it like that. Or if you want, you can put a plus and do a dot, dot, dot. Doesn't really matter. Okay, so guys, now that we've added series, you need to be very careful. You need to look at the information that they've given you. If they're giving you the sum, then you use the sum formula. All right? If they're giving you a term, you use the term formula. Or like in this case, they've given you the sum of two specific terms. So not the sum of term 1, 2, term 10 here. They're giving you the sum of term 2 and term 6. Then you need to use the term formula twice. Okay, and then work from there. But usually with these types of questions, you will end up having to solve simultaneously. Okay, some questions, guys. Are we feeling about this? Okay, you're going to practice it now, right? So I'm going to ask you to do exercise 1.5. Yeah, which is 45 minutes. Second break, that's quite nice. Now guys, for number 1, they say evaluate the sum. They basically just mean find the sum. Okay? I don't know why they use the word evaluate, but if they say evaluate, they just want the actual sum. So I want you just to do 1E, that's just practicing using the actual formula. One E. I don't really know why I put a point there. I don't normally do that. 8. And number 12. It might look like a lot, but guys, we still have half an hour left. I'll just make that. No, I'm lying. 15 minutes. Okay, you might be able to finish this in 15 minutes. So. Yes, it will be for 150 minutes. Yeah. All right. If you don't know, yeah, it's on multiple pages. I want you to put it up. Okay, let me change this one to just 7A. How's that? Instead of 7A, I 7A. So guys, I just want to give you a hint. In number 4, I'll put it on the board now. The wording is slightly different from what we just did, but I just want to help you with that so that you're not confused. In number 4, they're saying how many terms are there in the arithmetic series? -14, -10, -6. And guys, this is a little bit strange, but just if you have minuses here, that just means that the terms are negative, but it's still a series, right? So you could actually rewrite this as -14 plus -10. You don't have to, but I'm just showing you that it is still a series, okay? And then plus dot, 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 and then plus 46. So what is your constant difference in this case? What are you adding? To go from -14 to -10. We're adding 4, right? Your first term is this -14 now. That's the only thing that's actually different. Your first term is -14, but you are adding 4. That is your constant difference. Now guys, this, what they put here at the end, that is the last term. Do we notice that there's no plus dot 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 after that? Okay, so they've given us the first three terms, and then they're giving us the last term. Now I'm going to ask you a question. If a number pattern or series has 10 terms, right? You can have 10 terms. Which term is the last term? Term 10. You know, ask that question again. If a number pattern has 10 terms, which term is the last term? Term 10, right? So what you're going to do here, you're going to make this 46. Do we agree that this is not a sum? 46 is not the sum of the series, right? So we can't make this equal to Sn. We're going to make this equal to term n, because it is a term in the number pattern. We're going to calculate what n is. Say n is 12. Then how many numbers are in that number pattern? If the last term is term 12, then there are 12 terms. Does that make sense? I'm just going to say that again, right? They've given you the first three and then the last term. This is not a sum. If there was an equal there, 46, then they've given you the sum. All right, but there's a plus 46 and then it stops. So this is the last term. So you're going to make 46 n. Solve for n with your a plus n minus 1b formula. Okay, we've done it a couple of times. Solve for n. Say n is 12 here. That means that there are 12 terms in the number pattern. Because that's the first question. How many terms are there in the series? They're not asking which term is 46, right? They're asking how many terms, but you have the exact same method. Because you need to know which term this is in order to know how many terms there are. All right, so you're just going to solve for n here, basically, for the first one. And then for b, now they're asking for the sum. So if your answer here is 12, then you're going to find the sum to 12. Does that make sense? Okay. That's not the first one, that's 4. That's number 4. You have to do 1e first. Yes, 12 terms. 12 and so if they're saying to 12 terms, they're just saying that you have 12 terms that you're adding together. So n is 12. In 1e, 6. Okay, get going, guys.